The last application we're going to look at is distance equals rate times time. And you might say, well, that's not a ratio because it's an equation, but the way that we're going to rearrange it will make it turn into a ratio. So let's take a look. We have an athlete's speed on her bike is 14 miles per hour faster than her speed running. She can bike 31.5 miles in the same time that it takes her to run 10.5 miles. So we're trying to find her speed running and her speed biking. We don't know either one. So let's let x equal her speed running. Speed, of course, is the same as rate. Now we know that she can bike 14 miles per hour faster, so x plus 14 would be her speed biking because it's 14 faster than her speed running. So there's my two speeds. That's my rate and my rate. They also give me the distance of each. So distance and distance. What they don't give me is time, but they give me something more important than that. It says that the two happen in the same amount of time. So what I want to do is I'm going to take this equation, d equals rt, and I want to rearrange it to get time all by itself, which means I'll divide by r. If I divide by r, that tells me that the time is the same as the distance divided by the rate. So I do have distance and I do have rate, and I know their times are the same. So if I take her distance running is 10.5 over her rate running, which is x, that should equal her distance biking over her speed biking. So now I've got something I can actually solve. So let's cross multiply. 10.5x plus 147 equals 31.5x. I would, of course, get all of my x's to one side of my equation. I'm choosing the right side because I feel like it. And 31.5 minus 10.5 gives me 21. And when I divide by 21 on each side, I get that x is 7. X represented her speed running. So her speed running is 7 miles per hour. And her speed biking is 14 more than that, so 21 miles per hour. So her speed running is 7, biking is 21. For this question, we have a cross-country skier. So Devin can cross-country ski 5 kilometers per hour faster than her sister, Chanel. So Devin skis 45 kilometers in the same amount of time that Chanel skis 30 kilometers. Again, same amount of time means that I'm still using t equals d over r, and I'm setting the two times equal to each other, or the same distance over rate. So Devin can cross-country ski 5 kilometers per hour faster than her sister. So I'm going to say that Chanel's speed is x, and that Devin's speed is x plus 5. That's the rate. So Devin skis 45 kilometers, that's her distance, divided by her speed of x plus 5. And then Chanel is 30 over x. So distance over rate. And then we cross multiply. 45x equals 30x plus 150. I subtract the 30x from each side and get 15x equals 150. And of course, dividing by 15, I find that x is 10. Remember, x represented Chanel's speed. So Chanel is 10 kilometers per, pretend that's an M, 10 kilometers per hour. And Devin, her speed is 5 faster than that, so 15 kilometers per hour. This is a Similar question because we are using distance, rate, and time, but it's not similar because if you'll read over the question, we find that the two times are not the same. We find that the total time is 2 hours, and therefore I can't just set two ratios equal to each other to solve. So this will be more difficult. The two values that I'm trying to find are the speed of the train and the speed of the bus. So I'm going to let x represent the speed of the train, and I'm going to let x minus 24, because the bus is 24 kilometers per hour slower, equal the speed of the bus. Now I'm still using that same concept I did before, which said that time is equal to distance divided by rate. And so when I'm working through this question, I'm going to represent time as distance divided by rate. So let's first look at the time on the train. The time on the train would be 70 kilometers, that's the distance, divided by the rate on the train, which is x. The time on the bus would be the distance on the bus, which is 30 kilometers, divided by the rate on the bus, which is x minus 24. I'm adding those because it says the total time traveling, which of course means time plus time, equals 2 hours. So now I have to solve this. So solving, when I have a rational equation like this, I'm looking at that denominator and finding the LCD and multiplying everything by the LCD. My LCD here would be x and x minus 24. So that's going to be my LCD, is x times x minus 24. I'm just going to write that on all three terms here. Oops, that's supposed to be an x. And this times x minus 24. Just as always, I'm going to do some cancellation. Woo! And that gives me 70 times x minus 24. Notice I've kept it in the parentheses. The x minus 24 would cancel, and I'd have 30 and x. And here I could multiply it all out, but I'm going to go ahead and multiply those two and then keep this in parentheses and do it on the next step. Now I'm going to distribute 70x minus 1,680 plus 30x equals 2x squared minus 48x. I've got a real mess of an equation here, but let's go ahead and simplify a little bit more. This 70 and this 30 will come together to make 100x minus 1680 equals 2x squared minus 48x. So right now I've got a little bit of a mess, but I know that it's a quadratic mess. It's quadratic because I've got an x squared value, and that's not going to go away. And I've got an x value, and I've got a constant value, and so it makes the most sense in a situation like that to move everything to one side and set it equal to 0. So I'm going to subtract 100x from each side. I'm also going to add 1680 to each side, because that gives me on the left side nothing. On the right side, I have 2x squared minus 148x and plus 1680. Now I need to do some factorization. So I'm going to actually go ahead and take a 2 out of everything to make those values just a tiny bit smaller. And that gives me x squared minus 74x plus 840, all equal to 0. And of course I could do the quadratic formula, but I know that I'm going to be dealing with some massive numbers with this 840. I'm going to try factoring. So I'm looking for two numbers that multiply to 840 that add to negative 74. So what two values could that be? By breaking 840 down into different factors, I managed to find that if I multiplied 60 times 14, that those do give me 840, and they do in fact add to 74. So my factorization is that 2 on the outside, and then x minus 60 and x minus 14. Now, by setting x minus 60 equal to 0, I find that x is 60. And by setting x minus 14 equal to 0, I find that x is 14. But I really only need one answer, so let's think about what makes sense. 14 kilometers per hour, if that were x, what would be the speed of the bus? 14 minus 24 is negative 10. So even though 14 is a positive value, it doesn't make sense in this question because the speed of the bus would not be negative. So I know then that x is the speed of the train, and so the speed of the train is 60 kilometers per hour, and the speed of the bus is 24 less than that, which of course would be 36 kilometers per hour. Last one for you to try on your own. So press pause, do the question, then press play to see how you did. Just as in our last one, we are going to have x to be one rate. So in this case, I'm going to say x is the rate of the train. And I'm going to say that x minus 20 is the rate of the car. And again, we're using that same concept, the distance or the time equals distance divided by rate. So the time on the train is 210 miles on the train divided by the rate of x. The time in the car is 50 miles, and then of course divided by the rate of x minus 20, and the total time is 4. Our common denominator would be x and x minus 20. And I would take that times everything, x minus 20. For my first, my x's would cancel. That would give me 210 multiplied by x minus 20. For the second, the x minus 20s would cancel. That would give me 50 times x. And then for the last, I would go ahead and multiply that 4x and then distribute on the next step. Now I'm going to distribute the 210. So 210x minus 4,200 plus 50x equals 4x squared minus 80x. Moving everything to one side of the equation, I would have 4x squared. That would be 260, and that would give me 340x. And then of course that 4,200 all equal to 0. And I'm going to go ahead and simplify it just a little bit further by dividing everything by 4, which gives me 85x and 1,050. So now let's look for numbers that multiply to 1,050 that add to 85. Factoring that, I would get x minus 70 and x minus 15, which of course means that x would be 70 or x would be 15. Just like on our last example, the 15 doesn't make sense. And so I know that the train must be 70 miles per hour. And the car is 20 less than that. Of course, I couldn't take 20 away from the 15. That's why it wouldn't make sense. So that means the speed of the car is 50 miles per hour.